So when you click on its EMU8086 icon, this particular window will pop up. Okay, so it shows 4 options: new, code examples, quick start tutor, recent files. That is, once you are having some experience towards that, you can always see. If you want to see the quick start, you can use the quick start tutor. Fine, you can see the examples by clicking on code examples. Fine. So we will start with new one. Just click on the new. You can, if you're not having the software, just note down the steps. Fine. And this session has already been recorded with the CSA. Fine. So there is no need to record the session. So just click on new. After clicking on the new, you will see that templates, which code template you want to create. It is asking COM template, exe template, bin template, boot template, or empty workspace, or the emulator file. And the last checkbox is using flat assembler or Intel syntax. So right now, since you are at the beginner stage, I'm not asking all to click any of it. Don't click on any radio button or checkbox. Just click on simple empty workspace. Just click on simple empty workspace. All right. So empty workspace पे click करो, then go to OK. Nothing else. Fine. So once you will be having a little expertise of programming, then you can choose the template. You want to create exe template, COM template, bin template that you can use, boot file, anything can be made. Fine. But since we are beginning right now, so just go with the empty workspace. All right. So this thing will be a little interactive, so don't stay silent in your class. Just keep giving me the information that you have seen and you have understood what I'm trying to show you. So whatever we have studied till date, in the last 40 days, whatever we have studied, we'll be going to analyze and we'll be going to see what we have studied. So whatever I discussed, whatever I told you, you can verify everything by using the coding. So if I'm right at every place, you will find the logics fitting. You will find that your knowledge is accurate. Fine. So let's start with this. You can always start by saving your program and that you know the basic processes. So I'll start with the simplest code I can write. Let's say I'm loading a value immediately inside accumulator. So in order to do that immediate addressing mode suggests me move ax comma 1234h. Move ax comma 1234h, by which I'm loading the value 1234, which is my operand right now, into the register A. Alright, let's take one more value. Move bx comma 2000h. Alright, so I've loaded two values, one in A register, one in B register. Right? And what else do I want? Let's say I add them. Add x comma bx. Let's add these two values, and I'm creating a very simple program, shortest, effective to understand. Fine. So in the last class I told you something. Whenever I create a program, what should be the last instruction of my program? What should be the last instruction of my program? Anyone? I specifically told you in the last class that there is one particular instruction you need to write, and that particular instruction is called HLT. HLT. All right. HLT will be the last instruction of your program. Anyways, so let's get back to the program. So So after clicking on this particular thing, after writing few instruction programs, what you need to click on, you can note down the next step is emulate. Since this is an emulator, fine. So what you will be doing is emulate. So this green play button, something like this green play button next to the compile, you have to click on this emulate. Fine. So when you click on this emulate, two windows will appear on the screen. One window will show your original source code, this one, and one more window showing you the other blue things, and there are some indexing inside this. So we need to understand something from this place. Okay, so these two windows are actually trying to give you information about the information program, what is happening in the program. Everything will be shown here. So what is happening here, the original source code window, that is been given in a small window having a yellow highlighter in the background, and there is a bigger window having some blue background highlighting. Fine. So what is happening right now, you need to understand these two windows. So in original source code window, that blue highlighter means that currently your pointer is at this particular instruction. Currently your pointer is at this particular instruction. Alright. So whenever something is being executed, fine, that pointer will execute this particular location and the pointer will move. But there is a clarity I want to provide. Having the pointer at some location like this move x comma 1 2 3 4, this doesn't mean that this thing is getting executed. It is only getting pointed. Fine, this particular instruction is only getting pointed. So next, what we have in this particular window, what it is showing us in the blue highlighter. See, whenever we are talking about this these phenomena of processor, I've already given you the hierarchy, how the conversion or the translation of codes takes place from high level to low level to then machine level. So when this machine level things takes place, the code gets converted into the machine level via assembler. This is how it will look like. These numbers that you are watching right now, that 010000, this is a memory location on the left side inside this, but next to it there is something written B83412 BB002003. What are these? These are the machine codes received after translation of this move ax comma 1234 bx comma 2000 add ax comma bx then halt. So this whole program has been translated into the machine codes. In machine it will look like this: B8 3412 BB 0020 03 C3 F4. Fine. So whatever you are writing, there is always a confusion how it gets converted and how it will look like. Fine. So this is show to you. Move AX is what? Move AX is my opcode. Fine. So this opcode is now converted into a machine code, which is your B8. B8 means for a machine, move AX. Okay. 1 2 3 4. Where is 1 2 3 4? Look here. LSB first, then MSB. LSB first, then MSB, because it will read the LSB first, then MSB. This is the way to write. So this blue block, what it is showing, that blue block is your first instruction, which has been translated into the machine. It has not been executed yet. It has not been executed. It is only translated right now. Fine. So next, if I want to show you, I'll go single step execution. Fine. But before this, let's discuss what is in the left. So in code being translated and the registers here, look at this register side. You are having AX, BX, CX, DX, then H showing the upper 8 bits and L showing the lower 8 bits. Next we have code segment register, IP, SS, SP, BP, SI, DI, DS and ES. All those registers you have studied, they all are available here. Fine. So let's see how the program will execute but for that I'll take you step by step. Fine. So if you want to see step by step execution of your program, you need to click on single step. All right. So let's click on single step and see what's happening. So what happened? The blue block has been shifted from first block to next. Next again, if you see in the source code window, move bx is being highlighted now. This means pointer is right now pointing at move bx comma 2000h. So what happened? Let me step back. So previously, now look, what are the contents of A right now? 0, 0 by default. So once I click on this, move AX comma 1, 2, 3, 4 and I put it to the execution, what will happen into A? Just keep an eye over the contents of A. What is going to happen if my instruction is correct? 1, 2, 3, 4 will be loaded into the register A. Let's see. And it has been loaded. Okay. So this way your contents will be loaded into the registers. So my next instruction is move bx comma 2000h. So in this case again this blue highlighter, this blue highlighted box, it is showing move bx. The code for move bx is double B, and next is your operand that you have already provided in the program 0020 LSB first, then MSB. Fine. So what will happen? Single step. If I click on single step again, click on this again. Look at the contents of register B. Is it having anything? No, it's not having anything by default. 0, 0. So my instruction says after move bx comma 2000, bx will have 2000. Let's see, and it is having 2000 now. Fine. Now after this, what I'm doing is add ax comma bx. I'm adding the contents of ax and bx. Fine. So ax is having what? This is having this, and bx is having what? This is having this. Fine. So after the addition of particular two values, where the result will go? Where the result will go?
Sir, in AX register.
This is what I want to show you. Now look into the AX. What are the current contents of AX right now? If I click on it again, right now AX is having 1, 2, 3, 4. What will happen? If it gets executed, now it is having 3, 2, 3, 4. 20 has been added to the accumulator and the result is back into the accumulator. Fine. This is how these things will modify the contents of the registers. Simple. So when we click on it again, it will encounter an instruction which is called halt, and the emulator will give a message. It will pop up a message with that emulator is halted. All right. Now are you getting something? How this whole thing has to be done? Getting a little?
Yes, sir.
कुछ आया समझ में? How to do?
Yes, sir.
This thing is very simple. It's just practice. Not much. It will not take a lot of practice. Like, so let's break it. And this time I'm going to use the 8-bit phenomena, and I'll be using the 8-bit sections of the registers. Let's say I'm loading 1, 2 into the AL, and let's say 5, 6 into the AH, and let's say BL is having 60, and BH is having 17. Fine. So I loaded simple few values. This time I'm not going to do the add operation. Let's play with the instructions so that we can have a better understanding of few things. So let's start moving the bits from one place to another place. Let's say uh, BL is loaded by AL. That means the contents of AL will be loaded into the BL. And let's say move H comma BL, move H comma H, then move L comma BH. I just
एक्सक्यूज मी
created a
सर
random. Yeah.
सर आपने नंबर्स के बाद एच क्यों लिखा है?
H stands for hexa. Because in this particular processor family, whenever we are working in the processor, the moment you add a number, the number deals in the machine. The machine is set on a number system. So right now what we are working is we are having a base 16. Okay, so processor needs to understand whether the value is base 16 or not. Okay, if I remove this h, what it will take? It will take the values having base 10. It is a decimal value. If you provide an O, it will become octal having base 10. So right now when you are having more closeness to the machine, तो machine में जब भी आप number load करोगे तो उसका nature define करना पड़ेगा. That this number is having which base. Fine. So H means this is hexa having base 16. O means octal base 8, and there is nothing. Then it is decimal. और binary को आप 0101 में लिखोगे.
ओके सर.
Alright. ठीक है, तो नंबर का बेस प्रोवाइड कराना पड़ेगा, अदरवाइज योर प्रोसेसिंग विल गिव यू एरर्स. ठीक, कोशिश करना, लेट्स प्रैक्टिस विद दिस, प्ले विद दिस. कुछ नंबर्स लोड करो विदाउट एच, देखो क्या मैसेज आता है, इम्यूलेट करो, ट्राई टू अंडरस्टैंड द मैसेज, व्हाट यू कैन लर्न फ्रॉम द एरर. ठीक है, तो दिस प्लेटफॉर्म इज फॉर प्रैक्टिस. मेक मिस्टेक्स, discuss your mistakes, no problem. Even your knowledge may enhance the knowledge of all of us. All right.
Okay, sir.
Okay, so let's emulate this thing again. Okay, so now we have so much transfers. I just want you to observe closely. So first transfer is move AL comma 1 to H. AL comma 1 to H. Fine. So in this case, what's going to happen is 1 2 will be loaded into the AL. So I'm not going to explain the blue highlighted block again, the memory block. Let's go into the single step execution. Quick. Look into the AL. AL has been loaded with the 12. That means my instruction is fine. Next instruction says AH will be loaded with upper 8 bits of A will be loaded with 56. Let's see. Yes, 56 has been loaded. Move BL comma 60. Fine. The BL, the lower 8 bits of register BL will be loaded with 60. Let's see that. 60 done. 60 done. BH will be loaded with 17. 17. It will be having 17 here. But now my transfers will take place. Fine. So what is comma AL? The source is AL and the destination is your BL. Fine. So AL is having what? 1 2 and BL is having what? 60. The 1 2 will be loaded into the 60. But this is one thing I want you to see. Fine. So let's execute it. Move AL comma BL. So what happened? AL has been moved to the BL. So this is what I want you to. Let me step it back again. 60, then 12 shifted to BL. So what happened here? The source was AL and the destination was BL. Fine. The operation, if I tell you in your language, it is copy paste. Source The contents from the source has been copied and they been pasted in destination. It is not cut paste. ऐसा नहीं होगा कि source का instruction, source का जो value है data operand that will be destroyed. No, it will remain. Fine. You can see by yourself. AL की value को तो कुछ नहीं हुआ, but BL modify हो गया. Fine. Let's see it again. Next instruction says H comma BL. BL source है, H destination है. BL is the source and H is the destination. Now see what's going to happen. H is again having 1, 2. Okay. Are you noticing it? Source क्या था? BL. Fine. And what happened is source is BL 1, 2. It is being copied into the H. Now see what's going to happen next. Right now we are having BH comma AH. H is the source and it will be loaded into the BH. See what's going to happen. The value has been loaded into this thing. Now BH is the source and AL is the destination. So let's see what's happening. Nothing will happen because they both have the same values. Fine. Next what we have is the last instruction, HLT halt. Emulator is halted and your program is complete. So now you can see the register section. Are you able to see what values we are having? We are having the same value. So I just moved the same value across all the registers like this. Fine. So it's just a practice phenomenon. It's just a way of understanding and doing things in a better manner. So if you explore through this emulator window, there are a few options we have in file, math, debug, view. View is the more important part where you can see everything. Fine. But the most important thing here is flags. Fine. So that flags you need to understand. Okay. So let's have one more. Let's put up flag phenomena also. Add okay, let's do an addition operation. I modified the value of BL. Fine. I loaded the biggest number inside the BL and I'm going to add BL with AL. Okay, let's see if there is a carry. This is for carry check. Okay, and if carry is generated, we'll try to connect a loop. Alright, this is showing an error. Why it is showing an error? Because there is this complication with hardware. The moment you are having the biggest number, FFH, you have to write it particularly. There is a 0 should be placed always at the beginning of the biggest number. If it is of 8-bit, FF, it has to be 0FF. 16-bit ka hai to 0FF. Fine. I believe now it will work fine. Yes, not fine. So let's go step by step. What will happen in this first program? First instruction, move AL comma 1 2. AL will be having 1 2. H will have 0F. Next is BL will have FF. And next is BH will have 1 7. So now values have been loaded. Fine. So next operation will be your addition of AL and BL. So let's see the current state of flags. Right now what your flags are: carry flag 0, 0 flag 0, sign flag 0, overflow 0, parity 0, auxiliary 0. Only interrupt flag is on, all other flags are off. Okay, now let's see after addition is there any change. So we have done the addition. Now see the flags. Now you can see the carry flag is 1. This is set. parity flag also set, auxiliary parry also set, interrupt flag was already 1. Fine. So if this thing is giving a carry, you can visualize what is the carry. You can see the carry is happening here. Okay, so you can also observe your flags in between. Understood? Is that clear? Is that clear, everyone?
Yes, sir.
Fine. So let's do one more thing. Let's have add one more fun stuff to it. So quickly, because now you have seen how the flags will be operating. So let me put a label and let's create a jump condition. What we discussed in the last class. Let's create a branch. So what we have understood that after adding AL and BL, there will be a carry. Fine. So let's create a branch by using the instruction JC, because we know JC will check the value whether carry flag is 1. So JC stands for jump if carry flag is 1. Now we are not dealing in the memory location, so we can put the label. So let's put a label L1. Simple, nothing. This is just the one way to write. Now where do you want that label to be connected? Let's say you can connect it anywhere in the top or anywhere in the bottom or anywhere in the program. Fine. So let's say I put it here. The condition is you just need to place a colon where you want to connect the label. Label will be declared after the jump instruction or call instruction, but where you want to connect it, that place should be having a colon after the label. This is the only condition. Fine. So if this thing is fine, everything is fine in this, I'll show you how the loops takes place, how the looping takes place. Alright, so let's emulate this thing again. Alright, let's go single step. 12 will be loaded in AL, 0F in AH, BL in 0FF, sorry, 0FF in FF in BL. Next we have is addition. Now we have to observe something. If addition, I know carry will come definitely. This is the pointing now. Pointer is at JC comma L1. If my carry flag is 1, we can notice carry flag is 1, condition is satisfied. This is what I'm checking. If carry flag is 1, agar ye condition satisfied hoti hai, it will go back to L1. Fine. So let's simulate it. Yes, it is getting back. Now see the pointer. The pointer is back to L1 because the condition was satisfied. Fine. So what will happen to L1? It will again execute the instruction which is at a location move BL comma 0FFH. BL will be overwritten by the FFH. Now what will happen next? Now look closely. Same instructions will be executed and it will act like what? What is this happening here? तो बताएगा मुझे क्या हो रहा है?
Sir, infinite loop.
This is an infinite loop because the condition is already set. Condition is already set. Fine. So you can even modify this thing right now. If this thing happens, something happened, we are stuck with the infinite loop. We are stuck in the infinite loop. What should I do now? What should I do now? Somewhere I need to clear the carry flag. Where should I put the carry flag? Where should I clear the carry flag?
Sir, after add operation.
No. After addition, then jump will not take place. Fine. So this is a small program. I guess CLC will not work in this. So what happens? Let's understand the different condition. What if this condition will not operate? In place of JC, I'm using the JNC. Okay, let's understand both ways. So what will happen? JC will check for carry flag is equal to 1. JNC will check for carry flag is 0 or not. We know what is the state, but still I want to check the operation of both instructions. So when pointer is at JNC, now if this condition is true, it will go back to L1. The condition is JNC no carry. Carry flag is 0, not set. Fine. But this condition is false. So when the condition is not executed, what will happen to the assembler? The assembler will come to the next instruction. Simply, it will not go anywhere. So this is what I want you to understand. If the condition executes, the connector will connect it with the label. Otherwise, it will simply come to the next instruction. All right.